Hello and welcome to today's video on setting up an Ambrell Easy Heat Induction heating system with the Nanoparticle Heating Kit. First, we're going to go over the contents of the kit. Here we have a 7-turn coil, which is intended for running test tube experiments. We have a 4-turn Helmholtz coil, which is meant for petri dish samples under a microscope. We have a 3-turn large coil, which is for live rodent specimen. Here we have the vials that we're providing, both glass and plastic. There's also the insulating paper for insulating the vial from the coil. Here we have the tube that's used for making a nylon heat exchanger. And finally, we have what we'd call a fishtail. The first thing we're going to do is put the fishtail onto the workhead. Once the fishtail has been placed onto the workhead with the 4 screws, we'll put the nanoparticle 7-turn coil onto the fishtail. We'll use a 1/2 inch, or 12.7 millimeters, and 7/16 inch, or 11.11 millimeters, wrench. Alright, now that that's done, we're going to create a heat exchanger. I have a regular aluminum rod, and masking tape has been placed on it. I'll take this tubing and basically wind it around the rod to create the heat exchanger. Alright, once we have wound up the nylon tubing, we'll take the tape and bring it down on both ends to hold it in place. Alright, then after that we'll simply slide it off the mandrel. Make sure that the tape is not in the way. This creates a heat exchanger for the nanoparticle set. Alright, now the heat exchanger goes inside the coil. Feed one of the leads through. This is done because we run large currents on the coil, which can cause the coil itself to heat up despite the water running in the coil. Alright, now we'll use this piece to create an insulator between the test tube and the heat exchanger, as we don't want the heat exchanger to pull any heat away from the test tube. Alright, so I'm going to take this and wrap it around my vial. Alright, now that that's done, I'm going to insert it into the heat exchanger. Alright, this will insulate everything. We do recommend running room temperature air through this. So I have a small adapter, and they are just push to fit fittings. that you might need to adapt to a regular airline. This end can blow around, but you can just put it under something to hold it into place. Alright, now that we have the coil on and the heat exchanger in place, we need to measure the temperature. There are three options that Ambrell provides for temperature measurement. The first option is to use a temperature indicator or Fluke meter. It is the most simplistic option. The second option is to use the Photon control unit, and the temperature will appear on your computer screen. The final option is to use the Photon control unit and the Yokogawa unit in tandem, and it'll become a standalone system once it is configured properly. Here is the first method of temperature recording with the vial, coil, and a grinding dust solution is used in the test tube. We have the temperature indicator, which is a Fluke meter, and here we'll look at T1. Now bear in mind that the K-type thermocouple cannot be placed in the vial during heating. Alright, it's in the vial and you can see that we're starting at about 25 degrees Celsius. So, the process is to turn on the power for a certain period of time, and then you turn it off and measure the temperature. If you place the reader in the mixture during heating, it'll heat the wire and lead to false results. Alright, now that the heating has concluded, we'll measure the temperature once again. And you can see that the temperature is now up to about 39 degrees Celsius, up from 25 degrees Celsius. And that concludes this demonstration for the first method of temperature recording. If we're providing the Photon control unit, it looks like this. It comes with a fiber optic, and you'll need to provide 24 volts to the section that says power. It says plus minus, and it's relatively easy to figure out. This is the fiber optic probe. In this case, I use black as my ground and green as my positive. If you want to use red and black, that's fine too. It won't make a difference. Alright, you can see the unit there. And since for this demonstration we are using an Easy Heat Large, we'll be using the power off the back of the Easy Heat Li. Those two wires connect to the terminals that state 24 volts positive and ground. It's on the side legend that's right there. So now that we've connected the power to the Photon control box, we have a flashing light. This means that something is not quite right. What it is indicating is that we do not have the sensor probe attached to it yet. This is a very delicate fiber optic. Don't kink it as it'll break the fiber. And it'll connect right here. It is a push and twist. I have a sample of a loaded material here, which is actually grinding dust, and I'll place it into the coil. This fiber optic right here will get placed into the sample. And then we'll just zoom in a little bit to give you a better view. There is a program, the TP Meter software, that will need to get installed. It is provided on a disk. Once it is installed, it'll be under the Photon control folder under the Start menu. Now you'll need to launch the program, and you'll get a screen like this. You'll need to connect your computer to the Photon control module. Here, I have a serial port connector. And since this computer doesn't have a serial port, I have an adapter. I'll simply insert this into the computer, and this into the slot that says RS-232. Once that's done, you'll have to tell the Photon control software which port the device is on, and then it'll start talking to it. Alright, you can see that I'm reading a temperature of 23 degrees Celsius, which is roughly room temperature. Once I turn on the Easy Heat LI, you'll see the temperature increase. Alright, the power is now on. As you can see, the temperature is in fact increasing. We are using grinding dust in this demonstration as nanoparticle solutions are typically under NDA. And when you turn the power off, you may see some residual heating from the particles mixing. Now, in this segment, we have the temperature control and photon control in a single device. What needs to be done here is connect the probe into the device. It is sent this way to prevent damage, so you'll need to remove the screws in the cover with a simple Phillips head screwdriver. Please note that there are 2 screws on each side also. This will take us a few moments to complete. Alright, we'll flip it around and do the final 2 screws. Alright, now we can remove the cover. Now that the cover is removed, we have the photon control device here. Here is the port where the fiber optic goes. Now you need to take the fiber optic, take the small side, and insert it right here towards the front of the device. And then you'll just need to pull it through. Again, the fiber optic is delicate, so try not to kink it or pull on it. And also, try to keep it from turning into a knot. Alright, now it is fed all the way through and connected, so now we can put the cover back on and secure all of the screws. Now the next step is to insert the probe into the vial. There's also two wires on the back of this. The one is a plug for unit power, of course, and the other wire is the control cable which will control the power supply. That will go into the remote input terminals in the power supply. On the back of the Easy Heat Li induction heating system is the remote input legend, which says that the positive is the bottom pin and the negative is the top pin. It is 250 ohms. Now we have to connect the two pins from the temperature controller unit to the remote input pins. Alright, we'll use a simple Phillips head screwdriver to secure them. Alright, they're now secured, and what this will do is enable the power supply to be controlled from the Yokogawa unit. Now, here's the setup. You'll notice that the Yokogawa unit believes that room temperature is 43 degrees Celsius. That's because the Photon control box needs to be properly scaled. So, we need to go into the Photon control software, go to the Help pull down, and go to Login. So we'll do that in a moment, and the password is user, which we'll enter momentarily. Alright, the password was just entered. So, we'll need to connect the Photon control and temperature controller box to the computer. That is done with the RS-232 wire. It connects into the hole on the back of the Yokogawa unit. Now, the computer is connected to the temperature controller. Alright, now that's all set up, so we need to go into the software, on the TP meter software, and we'll tell it which communication port it is on. You'll see that the computer says 23 and the controller says 43. So, in order to fix it, we'll go through the Help menu, log in once again, type the password, click on the Settings menu, and select 0 and Span. So this needs to say 0 is 0, and the span is 80. Alright, this will properly rescale the Photon control analog output. Now you can see they are both reading the same value of 24 degrees Celsius. Alright, so what we've done is change it from manual to automatic mode. I'd like to run the program that is in the Yokogawa controller now. So I have to come over to the Easy Heat Li and tell it to accept the rear input. Alright, now we'll go into the menu. Use the right arrow until we see System Options, which we see right now, and then you hit Menu. Then I'll hit the up arrow until it says Control From. Right now, Front Panel is selected, and we want it to say Rear Panel. Once that's selected, the Easy Heat Li will automatically run from the Yokogawa unit. Alright, now we'll hit the Start button, and you can see that power is increasing as is the temperature, which you'll now see on the Yokogawa and on the computer. Given the setup, the Yokogawa is controlling the power to maintain a temperature of about 50 degrees Celsius. So you can see the temperature ramping up now. And for the sake of preserving a little bit of your time, we will fast forward a bit towards the end of heating. All right, and now we're at about 50 degrees Celsius. Now, depending on your sample, and in this case we're actually using grinding dust, and how evenly it is dispersed, there may be conduction up and down in the sample, which means it may overshoot the temperature slightly. But as you can see, we're within the 50 degrees Celsius range. And this concludes our third temperature measurement option demonstration and our video. This has been another training video from Ambrell.